the first question, you have to calculate the energy emitted, which is delta E. And in the information, the wavelengths for red and green line are given. Since the Planck's constant is 6.63 times 10 to the power of negative 34 joules second, and the speed of light is 3.00 times 10 to the power of 8 meter per second. So we got the idea to combine all in the equation of delta E equals to hc over lambda. Hence, the energy emitted for the red line is 3.031 times 10 to the power of negative 19 joule. And for the green line is 4.09 times 10 to the power of negative 19 joule. The second question is about to sketch the energy level diagram to show the transition of electron that produce the red, green and blue lines. This is how the energy level diagram looks. The vertical line is representing the energy level, while the lowest horizontal line is representing the ground state. As you can see, the distance between the horizontal lines are different. It shows that, the lower the energy level, the higher the wavelength. So now, let's find the clue to identify the ground state. As we know, there are 5 series in atomic hydrogen emission with different ground states. So, for this question, the information is about Balmer series because the lines that can be seen or exist in visible spectrum region. That means the ground state is n equals to 2. Let's mark the ground state as n equals to 2, then followed by n equals to 3, and so on. So now, is about the transition of the electron. Since the red line is formed and the wavelength is the highest, compared to green and blue line, it is understood that the electron is dropped from n equals to 3 to n equals to 2. Then, the second transition is when the electron dropped from n equals to 4 to n equals to 2, which corresponds to the green line. The next transition of electron that formed the blue line, means the electron dropped from n equals to 5 to n equals to 2. Once again, as a conclusion, when the electron drops from the lower energy level to the ground state, it will emit photon with a high wavelength.